All right. So everyone say hi to Brady.
Hi, Brady.
Brady's not here.
Brady Gardner, #1 quarterback.
Whew. All right. Which out of the three, this graph has the symmetry about what? The pole. So here's my question to you. How many quadrants should we make the table for? All of them? One of them? Let's try one. Is that okay? Okay. R equals 3 times sine of 4 theta. We're going to make the normal table like what we have done. But before we plot it out, I want you to hold on, okay? Let's start with what quad? 1, 2, 3, or 4? Okay. 0, pi over 6, pi over 4, pi over 3, and pi over 2. There are limitations, pi over 2. There are limitations to sort of plug it in and plotting it out. So why don't you go ahead and plug it all in and then give me all the radii. So the angle is 0. Tau, what was the radius for 0? 3. Pi over Sammy, pi over 6, what was the radius? Oh yeah, go for it. Oh, you have the answer? Okay, Carlos, what was the radius? Which is? Give it to me in decimal. 2.6. Someone confirm that for me? Is it 3.6? Is it 3.6? I mean 2.6? Yeah. Okay. What? No, that's wrong. 2.59. Oh, okay. So he rounded to 1 decimal. You rounded to 2. You get pi over 4. What was the radius?
Still calculating.
Okay.
The sine of 0 is 0. Where should it be 0?
I'm just writing what you tell me what I write. So 0 is wrong?
Yes.
Oh. It should be? 0. Much better. Okay, how about pi over 4, Yui? What was the radius? 2.12. Can we agree? Wow. What? We don't agree with this either? Oh my. We have a negative, we have a positive, we have a 0. It is.
Oh my.
Because shouldn't you multiply by 4 first, y'all?
Yeah.
Thank you. Okay. Zay, can you give me pi over 3? Please give me the right one. What is it? Someone confirm that for me? Yes. And then now back at pi over 2, Jordan, can you give it to me? Take your time.
Yeah. 0. Yeah.
Thank you. I know, it's Halloween, huh? Okay, so we are, notice how there's like a bunch of zeros and then the 2.6 and a negative 2.6? We're reflected about the pole, which means the x and the y, not or, but and, okay? But before I go and plot that, this is partially right. And if on the test and all I'm asking you to do is it's plug it in and chugging it out, then this I will accept. Excuse me. So let me plot it out. And then I'm going to do another way, which you don't need to know, but I want you to see it's a better way of graphing flowers, or in this case, a rose, okay? We'll start with 0, 0. And then pi over 6, I'm going to go about 2.6. This is somewhat okay, not its best. I plot 1 dot. That means I should go and reflect about the pole. Yes or no? So I should have another dot where? Quad 3? Or quad 2? Or 4? Quad 3, okay. By the way, you can plot it. Remember, it's reflective pole, so how do you want to reflect? Oh, well, x and y, so you can do x first and y later, or vice versa, really. What you want to do first? X first? Go down to 4? Yes or no? Okay, let's go down to 4. That's going to be right about there. Someone confirm that for me. Yes? No? Maybe? Okay, and then I'm going to reflect over the y. So now both quad 2 and quad 3 will have dots. True or false? True, okay. So that's going to be 1, 2, 2.6, and then this is over here, 1, 2, 2.6. Okay. So look at that. One value, it got 4 dots in besides the pole. Then at pi over 4, I'm back at 0, so I don't need to plot that again. Then pi over 3, I would have a dots at negative side. So let's go to the negative. But technically, does it matter really? Okay, so let me just make another color for this one so you can see. Should I reflect it? Okay, over to quad. Okay, you can do x first and then y, or vice versa. Really, it's not important. You can go up first, okay, because you can reflect it over the x. And then now I can fold it to y, so would I have it in quad 1 and 4 as well? 1 and 4. How many dots do we have?
9.
9. 9 with a center. You're right, we have 9 dots. But how many petals? 8, okay. So let me write, this is a rose with 8 petals. True or false? Because based on our exploration, if n is even, the number of petals always 2 n's, right? Double. I have 8. So technically, would you agree it might look like this? True or false? Something like this. Yes or no? Yeah. And the reason I'm just drawing this out is because we don't want any more. Guys, I can technically get all of these dots right here if I were to do like a pi over 10 and a pi over 11. Does that make sense what I'm trying to say? So if I were to pick every single radiance that I can think of, all of these will be dots. Does that make sense? But we don't have time to do all of that. Okay. So if this is somewhat okay, it's not the best graph, and here's why. And this is the part where I just want you to look at it. You don't have to, hey Brady, we thought you were absent, and so we like dedicated this video for you.
Brady said, I'll watch it.
Okay, so now that basic graphing, you're done. Okay, your responsibility is done. But if you want to go above and beyond, here's what, just kind of pay attention. You don't have to write the rest. Okay, so you are given r equals 3 sine of 4 theta. Is that okay with all of us? Okay. I can totally graph this by hand or on your calculator. Would you agree that you had, like, r is your y, so r goes here. Theta is your input, so that goes right there. Is that still okay? Okay. Now, again, you don't have to do this. You don't have to copy this. I would, if I switch the variables, can I go, instead of r and theta, it looks confusing, can I go y equals 3 times sine of 4x? Would that be okay? Yeah? So, x and y. Just kind of mimicking what you already know. So let's look at the period really quickly. What's the period here? Yeah, pi over 2, because 2 pi divided by 4, which is technically pi over 2. Okay, so, oops, I have too much popping up. Pi over 2. So here's what I'm going to do. I'm going to go, hey, here's a pi over 2 right here. Here's the next period, which is a pi. Because we normally graph a full revolution. Can I go all the way to 2 pi? Okay, so that means I just have a lot of periods. Okay, so this is 2 pi. Yay, nay, maybe? This is 3 pi over 2. And in each period, I have 4 tick marks. Can you guys agree? Yep, okay. So what I'm really trying to show you is this is what it looks like in the regular graph, and then how does that translate to polar? Would you agree the amplitude is 3? Yeah, okay. So 1, 2, 3, 1, 2, 3. Okay. And I could even go like a negative pi over 2 on this side as well. Not important, but if you really want to see that. So let's start with the sine graph. Sine is 0, 0. And then the next tick mark over goes 0, 1, but because the amplitude is 3, so would you agree that's 0, 3? I mean, not 0, 3. The next tick mark over is up to 3. So we'll start at 0, 0, go up 3, go down at 0, and then go down at negative 3. Here's one cycle. Yes or no? Yes? No? Maybe? Okay. Remember, I'm going to try to graph it all the way to 2 pi, because that's what we did with the full circle and just repeating. And this is just the part I want you to understand. And this is sort of how they come about graphing. Polar is kind of connecting to what you already know. Okay, there you go. So what's the highest y value we have? Yeah, 3. Guess what that really is? Guess what the largest radius is? Technically, it should be at? Guess what the largest radius is? Technically, it should be at 3, technically. Okay. But because graphing by hand without a calculator is kind of limited, you don't know how to find. If this is pi over 2, half of that's pi over 4. And then if this is pi over 8. Is that okay? Graphing by hand is a limitation. You can't find everything by hand, such as a pi over 8 or multiple pi over 8. Does that make sense? So the most you can find are the ones you know, like pi over 3, pi over 4. So can you see pi over 4 is 0, which kind of correlates to our table. So these are all where the top of my rows list should be. Can you see that? Like a pi over 8 right here. Okay. So technically, if I were to graph this a bit correctly, pi over 6 right here is at 2.6, but a little bit underneath that is where the 3 should be. Does that make sense how that's supposed to go? So that's why this is a better way to graph that, but there's limitations on that. So if you want to get super cool, you can do that and then stretch it over. So at pi over 8, you can even go like a little bit here. Okay, so technically, let's go like this. Can you guys see that? Technically. Okay, the dot is still there, so you don't have to fix your paper, but technically the purple one is where it's supposed to be. So, correlations. Can you see it? Yeah, pretty cool.
So could we just do a table instead for like regular sine and then go back?
And then transformed it?
Yeah.
Yeah, for sure. These are just transformations still. As long as you know it's a rows right away, and then you can do a table. Okay. But I would totally accept this right here, class, for full credit. Does that make sense? Because you're not going to know the pi over 8 by hand. Okay. All right. Let's move on to the next one. Oh, okay. Look at this. Can you do this? Okay. Well, not by hand, but with a calculator.
Oh, let's do it. All of them.
Which one's like the coolest one to do?
The last one. Or like the second to last.
No, the one above the last. 19. The last one. Yes. 8, 7.
So you have this is the rows right here. Just change your n. And then the rest, this is a limit sum with the inner loop, right?
Yep.
Yeah. So if you are bored in your other classes, you can take out your math notes and mess around. Okay. You can write like a hidden message. Flowers, yeah. Yeah. Okay, we can't do that right now. Let's go do this. I still need to finish this by hand. R square equals 4 cosine of 2 theta. If you see an r square, by the way, someone take a wild guess. What shape is this?
A circle.
No, sir.
Okay.
Is that the propeller? It is a propeller. Because we have to identify the ship. Okay. So it is a propeller. Okay, so let's start with the symmetry test. What's the first test? Polar axis. By now, we should know that to replace theta with negative theta. Okay, here we go. R squared equals 4 times cosine of a 2 times negative theta. But it's cosine positive or negative. I mean, not positive, even or odd? Even. So what's happening to the negative angle? It disappeared. So true or false? Can I accept this? Yeah, for sure. It works. Okay, so once I'm done with one, am I done?
No.
No. What if there's more? What's the next test? Okay. All right, replace what with what? Theta with pi minus theta. All right, let's check it out. R squared equals 4 times cosine of 2 times pi minus theta. Ooh, sum of difference of the cosine? So this is R squared equals 4 times cosine of 2 pi minus 2 theta, right, y'all? All right, R squared equals, what's this difference of cosine identity? Cosine 2 pi. I know, me neither. That's okay, me neither. Cosine 2 theta. Anything go to 0? Okay. What's cosine 2 pi? Positive or negative 1? Just 1. So R squared equals, oh, is it identical? Oh man, another symmetry. Should we check some more? No, thank you. I don't think you have a choice. Pole? Replace what with what? What? Does it work? Because everything squares is the same, right? Okay. I'm with Brady. We're not feeling 100%. Okay. So I'm with you, bud. All right. So I love it when all three works. If all three of them work, how many quadrants do you need? What? Just one.
That's what I said.
Especially the pole, if the pole works. Honestly, on my homework, I would start with the pole. Why?
Can't we just do the pole if the pole works just like
Right. Because isn't the pole symmetrical about the x and y? So on the homework, I would start with the pole and then go backwards, you know? Okay. So let's do quad 1. Theta, radius is r squared equals 4 times cosine of 2 theta. Be mindful, this is r squared, so you're looking for radius. Should you take the calculator and square root? Please do. Okay. 0, pi over 6, pi over 4, pi over 3, and pi over 2. Okay, so let's find r squared first. 2 times 0 is 0. Cosine at 0 is not 0, but 1. 1 times 4 is 4, but that's r squared, right? R squared is 4, so that means the radius is 2. So that's why I want you to be very cautious. All right, go ahead and do the rest. And then I'll just call on 1, 2, 3, 4 of us. Okay. Dylan, you're in charge of pi over 6. Kingston, you're in charge of pi over 4. Carrier, you're in charge of pi over 3. And Cole, you're in charge of pi over 2. Give me just R, okay, y'all? Dylan, did you get just the radius, Dylan, for pi over 6? Square root of 2? Someone confirm that for me? Someone be very careful for me, please. Is it just square root of 2? Ah, isn't r squared equals 4? I'm sorry, 2. Isn't r squared equals 2? Oh, sorry. Then that means go back and put plus or minus on on the other one. My bad. I forgot. R squared equals 4. That means r is plus or minus 2. Same thing with this. R squared equals 2. So r should be plus or minus rad 2. R squared equals 2. Okay. Kingston, did you come up with pi over 4? 0. So r is 0 still? R squared is 0? Okay. On pi over 3, Kara, did you come up with pi over 3?
Yeah, I got the value equals -2, but then I don't.
So does that work?
Rad over -2.
R squared equals -2, right, Kara?
Yeah.
Guess what? It doesn't work. You can't grab I in polar. I has its own coordinate. So guess what? How about pi over 2? There's none. Okay. But you have plenty to graph. So at 0, you have a radius of a positive and negative. So there you go. Does that qualify? Positive and negative radius. Yeah, pi over 6. You also have a. By the way, can I reflect those 2 dots? Number 1's already reflected by the y, right? Can I tell me what the x? No. So there's not much I can do. It's already reflected on its own. How about pi over 6? You have a positive and negative rad 2, which is about 1.4. So 1.4 is right here, and the negative 1.4 is right here. True or false? But I need to have reflection. You want to do reflection over the x first?
Yeah.
Okay, so if I reflect both dots over the x, I would have one down here, one up there. If I reflect over the y, what happens afterwards? Is it the same dots? Yes or no? Yeah, so guess what? It's done. Now, at pi over 4, you have a dot right at the pole. Okay. So, does it look like you have enough dots for your propeller? It's a bow tie, yep. It's a propeller. Hence the name. Okay, last one. Okay, here's a hint on your homework. If you see the variable, not the variable, the number e, it's all calculator, okay? All calculator. If you see e. All right, punching calculator. E, r equals e to the theta divided by 4. What does it look like? And then we'll come back. Check out your calculator. What does it look like? And then we'll come back and see. Oh. And then if you increase your window by x theta instead of 0 to 2 pi, and make it even larger. Yeah, it looks even more interesting the more you increase your window on the theta.
Oh wait, it's not low. That's not a problem. That could be a problem.
Anybody let me know if you're having a problem with graphing. Let me see it for you. Okay, go to the window. Yeah, go to the window.
I have mine.
Whoa. Radian.
And the bigger the window, the better. Anybody having problem? Go back to Michael's. Or each, okay, go to the window. You got negative 10 to 10. I don't want negative 10 to 10. Do 0 to like 4 theta. I mean 4 theta, 4 pi of it. Or 8 pi or 6 pi. And then zoom fit. Okay, zoom. And then zoom fit. Sorry. Each of the mode. You don't do Greek. Anyone is having an issue?
Oh wait, why did it? I thought you were missing a point.
Oh,
I'm not racing.
the bigger, the more cycles.
I hate you.
Your window on the theta, you mean? You can go like 0 to like 10 pi maybe. Have more revolutions. Now, on the test or on your homework, if this is on your homework, obviously you can use a calculator. On the test, I may not ask you to graph it out. I might just ask you to test for symmetry. So maybe let's practice that, okay? By the way, what is this? Do you guys know what this is called? Huh? A spiral? Yeah. Yeah, it's a spiral. Okay, here we go. Symmetry test. Let me ask you this. By just looking at your graphing calculator, is there a symmetry? No. Okay. So that should correlate. Do you guys want to do the work or no? No symmetry? Okay, no symmetry. Okay. As you know, it is, because there's no symmetry, you have to do the table for all of them. But the nice thing is you already have your own calculator, so I just need the points from your calculator. So let's start with, I'm going to do the key ones. Not all of them. So let's start with 0, pi over 2, pi, 3 pi over 2. That will give me 1 full cycle. Are you guys okay with that? But here's the interesting part. I'm also going to make another table for the negative revolution, because I want to show you how interesting it is. It just in your calculator, can you hit second table? It should give you the output for R already. The second table. There's a table button. Where's the table button? Yeah, hit graph. Okay. Can you see like all the values already? You can change. Okay. So, did you guys know that was there? No. Oh. Okay. So that's how you get the outputs if you choose to. But remember, if you look at your calculator, the theta is by 1, right? Like 0, 1, 2, 3, 4, 5. So let's do 0. At 0, what's the radius? 1. Now at pi over 2, because I have to graph it by hand, I don't have a calculator. What's pi over 2? Someone punch it in. You can even trace in your calculator if you want to. Hit second, I think it was trace. Right, and punch in pi divided by 2? 1.48, thank you, 1.48. Anybody not know how to get these values just straight up from your calculator? How about pi? Can you hit second trace, value, punch in pi? What is the output? I'm sorry, what is it? At pi, just right at pi. You got 0?
Wait,
At pi?
To the x or the y value? Oh, that's the y.
Yeah.
Oh yeah, I'm looking for the output, y'all.
Does that mean the x value or the y?
What? E to the pi, 0? Pi, so do me a favor then, can you do this, do by hand then? What's pi divided by e to the pi divided by 4? I want to make sure it's accurate. Make sure it's not tracing the wrong coordinate. It's tracing the inner point. at pi, someone e to the 2.19, yeah.
Yeah.
Guys, what your calculator is doing is tracing the inner point. So if you do it manually at pi, it's this way. How about 3 pi over 2? And I'll explain why it's giving you 0 soon.
Wait, I thought it was negative.
Yeah. Well, it can't be, well, according to what I have, it can't be negative because you got e to the positive power. Right, y'all?
Because it calculates as negative 2.5.
Oh, it's probably giving you the other side, which is going the other way. But manually, would you be, it's not going to be negative?
Yeah.
Manually? So can someone do manually for me 3 pi divided by 2? So 3 pi divided by 2 divided by 4, right? So that's theta. So what is that? 3.2, okay. And then 2 pi. So 2 pi divided by 4. So e to the 2 pi divided by 4 manually, just in case you're tracing pieces. It should be over 4. So e to the 2 pi divided by 4. What is that? 4.81, okay. So here's what happens when I do the larger one, the first revolution, which is I'm going counterclockwise, okay. So I'm going to start at 0 radians, I start at 1, then at pi over 2 is 1.4. So can you see if I'm going this way, so far it's going that way, right? And then at pi is 2.2, so from here it's like that. Can you guys see how that's going? And then 3.2 is 1, 2, 3 is right there. And 4. 1, 2, 3, 4. 4.8. So almost 9. Can you see if I was to go counterclockwise? That's sort of what it's supposed to be. True or false? All right. Now remember, I can keep on going, right? Because that's just where we ended. What if I were to go the other way, like clockwise? Such as if I were to take negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. Would it give me larger values than the first table or smaller value than the first table? Smaller. So why don't we verify and see? E to the negative pi over 2 divided by 4, what would that be? So manually punch on it, let me know. Is it, so when you punch it in manually, what did it give you? Yeah, 0.675. For the sake of simplicity, can I just write negative? I'm sorry, not negative. Is it negative or positive? You said positive? Positive 0.7? 675? Okay. How about negative pi? Punch it in manually. So my first dot is a 0.7. So remember, I'm going clockwise now. 0.5 or 0.4? 0.5, okay. How about manually punch in negative 3 pi divided by 2 divided by 4 and then e to the power? What is that value? 0.3. So what's happening as you're going clockwise? Okay, what was happening at negative 2? Negative 2 pi I meant 0.2? Okay, so if I'm going to plot this in red. Can you guys see that it's getting closer and closer to the pole? Yeah. So if you go clockwise, it's still making a spiral, except it's getting closer and closer to the very center. Okay. So that's why this is cool. You can go either way. It will never stop, by the way. So that's why it's cool.
When I do it, it just keeps saying this. Yeah.
Can someone scroll up? Is this the last assembly and before I answer these questions? Yeah, okay. You can grab a book and start Friday's homework, or not Friday, Friday's homework. Your windows is out.
All my life, I'm getting and then I'll probably take I'm like, I'm just hoping for like 1 or 2 pounds.
Whatever, it should work now, like you have, you don't limit the negative window.
I gotta like last.